Okay, so we are given the continuous random variable x, which has probability density function f of x, where it's defined as x over 9 in between for x in between 0 and 3, and 1 over 9 times 6 minus x for x between 3 and x. It is then 0 otherwise. We are asked to find capital F of x, which of course is the cumulative distribution function in this situation. So, deal with the integrals one at a time. Actually, the method for doing this is the same as when you've got one function. There's one minor tweak. Okay, so we're going to end up with a function that's defined over different ranges. There's just one tweak to find the second one here. So let's focus on the first one. Of course, when we find a cumulative distribution function, what we do is we integrate between the lower bound, which in this case is 0, and a dummy variable t, which will stand in place for our x for the time being, just to save confusion, and then we can replace it afterwards for our function of x. So I'm just going to integrate x over 9 in between the range 0 to t. So when I integrate this, x integrates to x squared, and then of course going to divide by 2, so 2 times 9 gives me 18, integrating between 0 and t. Okay, so we're going to substitute the value in, so I get t squared over 18 minus 0 squared over 18, which of course leaves us with t squared over 18. And so the first function is fairly straightforward. Now, in the second function, we are going to integrate this over the range from the lower bound, which is 3, up to t, but the difference is going to be, actually, what we're going to have to do is we're going to have to evaluate and account for all the probability that we accumulate from 0 to 3 in this function here. So in other words, what I want to do is I just want to quickly work out f of the upper bound, so 3, using that function. So I'm going to get 3 squared over 18, which is 9 over 18, which is a half. And you'll see how we use this in a second. So now, when I do the integration for this range, what I'm going to find is that f of x is going to be equal to f of 3 plus the integral between the lower bound, which is 3, and t, for 1/9 6 minus x dx. So there's a little bit of rearranging and things to do to this before I actually integrate. So I'm going to evaluate the f of 3, which I've already done here, so I can put this is equal to a half, plus I'm going to take that 9th outside just to make the integration easier. 1/9 between 3 and t, 6 minus x dx. Okay, so don't forget the half. The half is important because that half accounts for all the probability that's accumulated in the range 0 to 3. So remember, when I use this function for the second half, I want it to take that into account too. So now we're going to get plus, don't forget the 9th, the constant you took outside. 1/9 times, if 6 gets integrated, it's constant, so it goes to 6x, minus, if I integrate x, that of course goes to x squared, and I'm going to divide that by the new power, which is 2. I'm going to evaluate this over the range 3 to t. So we get a half plus 1/9 times, put the t in, so we're going to get 6t minus t squared over 2 minus, and we're then going to put in the value of 3, so we're going to get 6 lots of 3 minus 3 squared over 2. Okay, so I mean, this isn't necessarily difficult, it's just fairly long-winded, unfortunately. So we get a half plus a 9th. There's nothing I can do with the expression 6t minus t squared over 2 at the moment. That's going to actually be forming our cumulative distribution function, but I can evaluate this bracket here. I can use it on do it on a calculator if you want to. This comes out as minus 3 over 2. Sorry, it comes out as 27 over 2. My apologies. Okay, now Next thing to do is expand this bracket. I can't add this half to it and tidy it up, so I've got to expand this bracket first, and then I can add this half and combine it, and we get left with our function. So I get half plus. So it requires you to be able to do fractions. 6 over 9, so 1/9 times 6 gives me 2/3 t. 1/9 times minus t squared will give you t squared over 18. And then 1/9 times 27 over 2 gives me 27 over 18, which simplifies to give me 3 over 2. And that's why I made that little mistake a moment ago. Okay, so finishing off, a half adding to the minus 3 over 2 just means we get left with 2 over 3, so 2/3 t minus t squared over 18. Make sure that's clear, that's a t, minus 1. Okay, so we're almost there now. I've got a function t squared over 18 for the range x between 0 and 3. I've got a function t 2/3 t minus t squared over 18 minus 1 for between 3 and x. So let's just write this out in full. Remember, f of x is defined over several different things. Okay, so you've got to remember that it's going to be 0 for x less than 0. So it accumulates no probability before 0. It's going to be defined by x squared over 18 for 0 less than or equal to x less than or equal to 3. Now we're going to use this second function here that I got as a result of integrating yet a second function. So we're going to get 2/3 x minus x squared over 18 minus 1 for 3 less than or equal to x less than or equal to 6. And of course then finally we're going to finish off with 1, because by the time we get to the upper bound 6 we will have reached total probability, which is 1. So anything larger than 6 will be defined as 1. And strictly speaking, to define your cumulative distribution function, you have to define it over all possible ranges. So that's not just between 0 and 6, but what happens if it's less than 0 and what happens if it's greater than 6. I hope you understood that all. I hope it made sense.